guys, today we're going to talk about the Pythagorean theorem. So we're going to take a look at right triangles and how all of their side lengths relate. So first remember, a right triangle is a triangle with one angle measuring 90 degrees. In this triangle down below, it looks like it might be a right triangle. This angle looks like it might be 90 degrees. However, you must be careful because just because it looks like a right triangle doesn't mean that it is. In order to say that something is for sure a right triangle, you must be told so, and you might see a symbol like this one. That little square in the corner does notate that this is in fact a right triangle. If that's not there, or you aren't told anywhere else in the problem, then you cannot assume that a triangle is a right triangle. Some key components. We have the legs and the hypotenuse of a right triangle. The legs of a right triangle are the two sides of the triangle that are adjacent to, or touching, the right angle. So looking at this triangle, the adjacent sides would be this side, I'll call it A, and this side down below, B. They are adjacent to this right angle because they are the sides that are touching the right angle. So the hypotenuse then is the side opposite the right angle. So here's my right angle. Opposite from that, I have this side, which I call the hypotenuse, or I'll call it C here. Also, this is the longest side of the triangle. Your Pythagorean theorem. It relates the lengths of the sides of a right triangle. Be careful because it may not be applied to triangles that are not right. What your Pythagorean theorem says is that a squared plus b squared equals c squared. Now what these a, b, and c letters mean are A and B represent the legs of your right triangle. So as I wrote on the other slide, here I have A and B. These are the legs of the right triangle, while C represents the hypotenuse. A and B, it does not matter which one is which, as long as they only represent the legs. C will always be the hypotenuse, or the longest side of your right triangle. So now we're going to look at these four triangles and determine if each of the following are right. If they work when you use the Pythagorean theorem on the values, then they are in fact right triangles. So your theorem, a squared plus b squared equals c squared. I'm going to first identify my a, b, and c values and then plug them in and see if it works out. A and b are the legs, so I'm going to let a be 3 and b be 4. Again, it doesn't matter. You could let b be 3 and a be 4. But C is always the longest side, and that would be 5. So I'm going to go ahead and plug these in. My A is 3, so 3 squared plus B squared, which is 4, 4 squared. Does that equal 5 squared? 3 squared is 9, plus 4 squared, which is 16. Is that equal to 5 squared, which is 25? 9 plus 16 is 25. And that does in fact equal 25. Since this worked out, this is in fact a right triangle. I'll use a symbol for triangle instead of writing the words, and I may put this little box in the corner. That notates that this is in fact a right angle. To the right, I'll let maybe A be 12 and B be 3. Again, it doesn't matter which is which, but the longest is always C. So a squared, that'll be 12 squared plus 3 squared equals my c, which is 14 squared. If this works out, then it will be a right triangle. 12 squared is 144 plus 3 squared, which is 9, is equal to 14 squared, which is 196. From here I simplify. 144 plus 9 is 153, and that does not equal 196, so this is not a right triangle. Go ahead and try the next two on your own after pausing the video. For the first, you should have a no, it is not a right triangle, and for the second, you should have a yes, this is a right triangle. On the next slide, we're going to find each of the missing sides. So please remember your Pythagorean theorem is a squared plus b squared equals c squared, where a and b do represent the legs of the right triangle. while C does represent the longest side, which we call the hypotenuse of the right triangle. So in this right triangle down to the left, I have two legs. They're both measuring lengths of 1. It doesn't matter which is A and which is B, but I'll call one of them A and the other one B. We are trying to find the hypotenuse, which is already labeled as C. So A squared, that's 1 squared, plus B squared, that's still 1 squared, is going to equal C squared. 1 squared is 1, plus 1 squared is still 1, equals C squared. Adding these, I get 2 is equal to C squared. And now we need to solve for C. In order to do this, I square root both sides. Anytime you put in a square root, you must put in the plus or minus. So I have C is equal to positive or negative square root of 2. However, C is talking about the length of a side of a triangle. So that negative really doesn't do us any good here. So C is just the positive square root of 2. To the right, I am now trying to find B. So I'll label this other side A. I'm trying to find B, and 3 is my hypotenuse, or C, in my Pythagorean theorem. So A squared is 1 squared plus B squared equals C squared, which is 3 squared. 1 squared is 1 plus B squared equals 3 squared, which is 9. Subtracting 1, I get B squared is equal to 8. From here, I go ahead and square root both sides. We don't need the plus or minus because since we're talking about a length, as we saw before, our result is going to be positive regardless. So on the left, I have B, and it equals the square root of 8. Anytime you have a radical, always look to see if you can make pairs. I've got 4 and 2, and 2 and 2, so I can take out a pair of 2's. So this becomes 2 with the square root of this 2 left inside. So B is positive 2 rad 2. I'll do one more for you, and then the remaining 3 will be on your own. In this triangle, I'll let A be 5 and B be 2. Again, you can flip-flop them, doesn't matter. But C is always opposite the right angle. And I don't have my little symbols here, but there should be right angle symbols in these corners. So A is 5. A squared plus B, which is 2 squared, equals C squared. 25 plus 2 squared is 4 equals C squared. 25 plus 4 is 29 is equal to C squared. Square root both sides. And since we're talking about a length here, we don't need to put the plus or minus because we know it has to be positive. So I have just C is equal to the positive square root of 29. Go ahead and pause the video and try this slide and the following slide on your own. You should have started out with A being 3 and B remaining as a B in your formula to give you 3 squared plus B squared equals, and C is 6, so that would be 6 squared. All the way down, I got B squared equals 27. I square rooted both sides from here and got B as the square root of 27. I could pair up a couple 3's in that 27, so I brought those out, but this 3 had to remain inside the radical. So my B value is 3 times the square root of 3. For your last two, you should have found a C value of the square root of 26 and a B value of the square root of 95. That's all I have for you today. Thanks so much for watching and have an awesome rest of your day.